sometimes called related angles, and it's an acute angle. Acute angle is in between 0 degrees to 90 degrees. That helps to relate sine, cosine, and tangent to the first quadrant when the theta is not an acute angle. Okay, when we're not having acute angles, we want to think about acute angle, because when the thing become acute angle, we can think about right angle triangle. Okay, we can start to think about right angle triangle. Okay, yesterday we learned exact values. Do you still remember what kind of values got exact values? There are two types. Do you mean x's, the values? No? Multiples of 90 degrees. Okay, the first type is the multiple of 90 degrees. All the values on the axis, that will give you exact values. It's either 1 or -1 or 0. Okay, that's the values will give you exact values. Why is called exact value? Because let's have a look. When we put sine, okay, this calculator is just annoying. Trick. Okay, we use cosine the same. Let's say cosine 200 degrees. Okay, I press enter. Can you see, like, I press enter, that will give me still some value like contain cosine. And when I press control and enter, that will give me a value like, I can't really write this value exactly on the paper, because that's a like irrational numbers, infinite decimals, and it's not circulating. So I can't really represent this number correctly, like very accurately on the paper. But when I go for cosine 30 degrees, when press enter, that will gives me √3/2. I can write this number down on the paper, right? This number is an exact value. And when I write this as √3/2 is an exact value, I can express that on the paper accurately. Okay, 200, I can't express this accurately on the paper. I can just say roughly it's about 0.94. Okay, by using the unit circle, you will say it's about -0.94. But when I put cosine 30, I can say that's √3/2. It's exact. Okay, it's the exact values. So first type is multiple of 90 degrees. And the second type we learn is the 30, 45, and 60 degrees. Okay, those three angles. Why they are exact? Because we have those triangles, and we can find exact values for those triangles. That's the two types. But not only 30, 45, and 60 will have exact values. And we can see, let's say cosine 120. Let's go cosine 120. That's exact values as well, -1/2. Okay, cosine 120 give me -1/2. You can say not only 30, 45, and 60 gives you exact values. Some larger angles also can give you exact values. So, but like, there must be some connection with 30, 45, and 60. So the most accurate way to say is the angles, reference angle are 30, 45, and 60. They will have exact values. Okay, so if an angle's reference angle is 30, 45, or 60, that can be expressed as exact values. Okay, so as I said, 240's reference angle is 60. Okay, 240's reference angle is 60. So that's why cosine 240 can be evaluated as exact values. Now I'm going to show you how we can find reference angle. Give you any angles, how can you show the reference angle? So it's actually very easy. Okay, let's skip the supplementary angles and go to example 1. Okay, let's go to example 1. Write down the reference angle in the first quadrant for the following angles. So 138 degrees. Okay, the method is, let's draw the Cartesian plane. And draw 138 degrees on this Cartesian plane. Okay, where is 138 degrees? Okay, just roughly sketch it. in the correct quadrant is enough. Okay, I just need that to be in the correct quadrant. Okay, it should be somewhere about here. Okay, 138. I start from the positive side of x-axis and swap of 138 degrees. Okay, that's 138 degrees. Okay, so what is the reference angle? The reference angle will be the angle made by this angle line. Okay, by this angle line. Where's the angle line? Here is the angle line and x-axis. Okay, you draw the angle line, right? And you have your axis, right? You form some angles in between those two lines. You want to take the acute angle. Okay, you want to take the acute angle. By this angle line, this red line, and this horizontal red line, there will be two angles made. One is 138, and the other one will be this acute angle. You will take that acute angle as the reference angle. So the reference angle here is this one. So how large is this angle? 42. Okay, it's 180 minus 138. Okay, 180 minus 138. So reference angle is 42 degrees. Okay, reference angle is 42 degrees. Okay. 227. Okay, sketch that angle line by yourself first. 227, where that should be. Is that in this quadrant? Do you have it here? Where is the reference angle? Okay, the angle line and axis will form an acute angle. Where is the acute angle? Here is the acute angle. Okay, the angle line and the x-axis, these two lines. Always be those two lines. Okay, and you form an acute angle, and one is the obtuse angle. Okay, it's one acute and one obtuse, definitely. You take the acute one as reference angle. So how large is that? What's the size of this angle? Okay, yeah, 227 minus 180. How large is that? 47. So reference equals to 47 degrees. So only angle greater than 90 degrees or less than 0 degrees will have acute angle. Okay, only the angles greater than 90, less than 0 degrees will have acute reference angle. The angle in between 0 to 90 degrees, you won't find acute reference angle for them because they are already acute. So find the last one by yourself. Okay, find the last one by yourself. do we find 58 degrees for the reference angle for this one? Okay, the angle is in the fourth quadrant, and the angle made with x-axis will be this small angle here. So it's 48 degrees. Okay, so why we need to find reference angle? It's not only for fun, okay? Only say what is the reference angle for this big angle. So we want to evaluate something, okay? We want to evaluate something. We just not like find it and keep it there. So this is like step one, okay? This is step one, finding reference angles. And say, as I said before, when you have angles, give you reference angle as 30, 45, and 60, you can evaluate sine, cosine, and tangent, okay? You can evaluate sine, cosine, and tangent. Give them the exact values. So how do we do that? How do we do that? So first, cosine 210. I have no idea how large is this angle. I have no idea what is cosine 210. If I don't have the unit circle, I don't know what is it. So let's have a think. How we can convert that into an acute angle, which we're familiar with. So we will first change 210 into an acute angle. Okay, into an acute angle. So let's find reference angle for 210 first. I want to find a value that I'm really familiar with. Okay, I don't know 210, but I want to find the acute angle. Acute angle and the actual angle will be equivalent. When I talk about the actual angle and we talk about the acute angle, they should give me the same value. So we think about 210. Okay, which quadrant that should be in? The third. Okay, the third. Okay, what is the reference angle for this angle? Okay, I have 210. And the reference angle will be made with the x-axis and the angle line itself form an acute angle, which will be this angle here. This angle will be 30 degrees, which is 210 minus 180. Okay, then this will become really easy. We just need to think about two things then. Okay, first find reference angle. Second, think about the positive or negative of this value. So first, we find the reference angle. After we find the reference angle, step one is I will directly change 210 to 30 degrees. Okay, it's equivalent. Directly change it. That will equal to that, but not finish. It can't be that easy. Otherwise, all the value will become positive, right? Any 0 to 90 degrees angle will be positive for sine, cosine, or tangent. Let's have a think. In the third quadrant, so the cast, what is positive in this quadrant? Tan. Okay, only tangent is positive in this quadrant. So cosine will be positive or negative for this one? Negative, right? Cosine will be negative. But cosine 30 degree is a positive value, right? So we put a negative sign in front. Okay, because this angle sits in the tangent quadrant, therefore must give me a negative value. And when we talk about 30 degrees, when we talk about 210 degrees, that will be the same ratio, but it will be positive or negative. Okay, depends on which quadrant this angle in. Even though a couple of angles will all have like same reference angle, but it will be positive or negative. This is in the tangent quadrant, so that will be negative. Okay, what is cosine 30 degrees? Root 3 on 2, so this one will be a negative root 3 on 2. Okay, so cosine 210 will be negative root 3 on 2. Okay, cosine 210 will be negative. Cosine 30 will be negative root 3 on 2. Okay, have a look at the next one, 150 degrees. Okay, where is 150 degrees? where 150 degree will sit? Second. Okay, say it's about here. Here is 150 degrees. Okay, where is the reference angle? This line? This line? This will be the reference, right? What is the reference angle? 30 degrees. Okay, and we can directly change it to 30 degrees. That's the first step. Okay, change the large angle into the acute angle. Which quadrant is the second quadrant? Like, which is positive in the second quadrant? Sine. So sine is positive or negative? Positive. So I just have a positive sign in front. So you don't need to put any negative in front. So that's a positive value. So what's sine 30 equals to? 1, 2. So sine 150 will be 1, 2. Okay. Sine 150 will be 1, 2. Sine 30 will be 1, 2. Both of that two values give me 1, 2. Okay, last one. Tangent 330. Tangent 330. Okay, 330 will be somewhere around here, right? Fourth quadrant. Here will be 330 degrees. The reference angle will be the horizontal line and the angle line itself. So here will be the reference angle. You don't need to think about positive or negative for the reference angle. You just need to think about the actual, how large is that actual angle. How large is this angle? 30. Okay. The size is 30 degrees for this angle. You don't need to think about the direction, moving down or moving up. So it's just 30 degrees. So I can put that directly to tangent 30 degrees. Whose quadrant is this one? Cos. So tangent will be negative. So I put a negative sign in the front. So what's tangent 30? Root 3 over 3. So it's a minus root 3 over 3. Okay, so that's how we really evaluate like those values. Okay, can you see 210 got the reference angle 30, so I can have the exact values. 150 got the reference angle 30, I can find the actual angles. And 330 got the reference angle 30, I can find the exact values. And can you see 210, 150, and 30, they all have a reference angle of 30. Okay, they all have the reference angle of 30. So there will be 4 angles, 3 angles give you the same reference angle, okay, in each quadrant. In each quadrant, you have the angle with that particular reference angle. So all of those 3 got the same reference angle. And they are evaluated by the same way. Okay, they are evaluated by the same way. And if you can go up a little bit, the supplementary angles, okay, that's actually a formula. Okay, that is actually a formula. But I don't really want you to remember these things by using formula, okay? I don't need you to remember it. So the thing is, you need to know how to find those angles. So first of all, let's have a think. If 180 minus theta, if theta is an acute angle, where is 180 minus theta will be? Which quadrant 180 minus theta will be? The second? You mean the second? Okay, so let's put this. Okay, 180 minus theta, right? So I don't know how large is theta, but I definitely know that will be in the second quadrant if theta is an acute angle. So it will be here. So I will say this angle is 180 degrees minus theta. What is the reference angle for 180 minus theta? Yeah. So it be this small angle here. That angle will be theta, according to what is theta. So 180 minus theta's reference angle is theta. I can change 180 minus theta into theta, right? Change it into the reference angle. So what I can have is cosine theta. But which quadrant is this quadrant? Whose quadrant? Sine, right? Sine is positive in this quadrant. So cosine will be negative. So I will have negative cosine. Okay, I'll have negative cosine theta. So cosine 180 minus theta will be negative cosine theta. Okay, how about sine 180 minus theta? So you still have the same angle, which is 180 minus theta. So the reference angle is still theta, it doesn't change. So I have sine theta here. Will that be positive or negative? Positive, because I have sine, so it's positive. So that's a positive sine theta. So sine 180 minus theta will be sine theta. Okay, we have tangent 180 minus theta. So I can still change that to tangent theta directly, but that should be positive or negative? Negative, because that's in the sine quadrant, that angle. So tan will be negative. So that's the formula. Okay, that's 3 formula, but I don't want you to remember them. I want you to have the ability to sketch the angle, find the reference, and decide the quadrant, put plus or negative sign on it. Okay, positive, negative sign on it. Okay, so that's what we learned for today. Okay, basically we learn how to find reference angles and how to evaluate sine, cosine, and tangent values when the angle's reference angle is 30, 45, and 60 degrees. Okay, that is what we learned today. Okay, we have 2 more pages to go. This is something new, so I'm not going a lot every day. I want you to keep doing exercise. Okay, if you're not doing exercise, you will forget what I'm doing. Okay, so make sure you you complete the homework and do enough exercise. Yep.